During this course, you will learn how we use variable speed drives, also called variable frequency drives, adjustable speed drives, adjustable frequency drives, AC drives, micro drives, and inverters to accurately control the speed of standard AC induction motors. These are the objectives for this course. Since standard induction motors have a very limited speed range, a very special electrical component is required to supply variable frequency to an induction motor, which in turn varies the speed of the motor. These special components are called variable speed drives, or VSDs. Variable speed drives are motor controllers with the ability to change the speed of an AC induction motor. VSDs are powered directly from 480 volt AC distribution substations or from motor control centers. VSDs are normally mounted indoors in cabinets. They are rated by horsepower. Incoming power is 3-phase, 60 Hz, 480 volts AC. VSDs rated for 150 horsepower and larger are powered directly from 480 volt AC distribution substations, while VSDs rated for 125 horsepower and smaller are powered from feeder switches located in MCCs. AC induction motors are inherently single-speed motors that run at an almost constant speed as determined by motor design. VSDs allow induction motor speeds to be varied, eliminating the need to vary flow using throttling valves or dampers. The result is a system far more efficient than the use of constant speed motors. Note that efficiency decreases with decreasing motor load and with drives of smaller horsepower ratings. In a VSD, line voltage and frequency, 480 volts AC and 60 Hz, are converted to a DC voltage and then reconverted, called inverting, to AC at a frequency and voltage necessary to drive the load at a desired speed. An AC motor speed is directly related to the frequency, so that the higher the frequency, the higher the RPM or speed of the motor. The speed of an AC induction motor is directly proportional to the frequency and voltage supplied to the motor. If the frequency output of a VSD is changed, the resulting motor speed will be approximately equal to this equation. So, if a 480 volt, 60 Hz, 1750 RPM motor is supplied with 220 volt, 30 Hz power, the motor will rotate at approximately 875 RPM. VSDs used at SRS facilities have the ability to operate AC induction motors over a 10-to-1 speed range. The actual operating range is determined by operating restrictions and are generally operated over a 3-to-1 range in the SRS areas. These VSD features are particularly advantageous for the SRS facilities. Commands from the operator panel are sent to the logic block where operator information is converted into commands to VSD components to provide the output desired. The instrument panel is where VSD output information is displayed, such as output speed and output current. This is a typical control panel that contains operator controls and instrumentation. Facility-specific VSDs are discussed in other training courses.